Greetings. Let's find a question on quadratic equations again. Find the range find the range of the expression say x minus 2 divided by a quadratic equation, linear polynomial over quadratic equation. Numerator is a linear polynomial, denominator is a quadratic polynomial. So linear polynomial over quadratic polynomial is given where x is real. Okay, so how do you tackle this now? You have something like this, right? Expression is linear polynomial over quadratic polynomial. Now what to do? So how do we get this answer? You see, it is very simple. There is no big deal in this. So you don't have anything. This is like isolated quantity. So x minus 2 over x squared plus x plus 3. Let us say that let y is equal to this, or let y is equal to this, or we could say that y is equal to f of x is equal to this. Okay, now we can simply simplify this. So you simplify for x now. So from this you just cross multiply. X minus 2 equal to, so what we get, x square y plus xy plus 3y. Now you can rearrange this stuff. So we could get x square y plus xy plus you have minus 3y minus x plus 2 equal to 0. Now this is like a composite quantity, like an implicit, you have something like implicit quantity here. So therefore now we'll make it simple as follows: x square y plus, I have here xy and again we have x here, right? So I can take x common, so we have now y minus 1 plus 3y plus 2. Our remaining stuff is this 3y plus 2 equal to 0. All right, so now let's make this a quadratic equation in x. Okay, so in that case y becomes a coefficient here, so y multiplied by x squared. Now coefficient of x is like y minus 1 multiplied by x, plus you have 3y plus 2 term like this. Okay, so 3y plus 2, so term 1 says this is 3y plus 2 equal to 0. Now what could we do in this case is f of x can have any value y. Yes or not? This f of x can have any value y provided this quantity in x, this quantity in x has real roots. That means now you have like a quadratic equation in x. Okay, so you can compare with this. You can happily compare with your general quadratic equation. Your general quadratic equation in x is ax square plus bx plus c equal to 0. So this is general quadratic equation in x. In x is this. So now you have this quadratic equation again in x. Okay, so now a corresponds to y, b corresponds to y minus 1, and c corresponds to 3y plus 2. All right, so now what could we do? Now we are, anyways x is real, right? And this quadratic equation must get anyways real roots. So if you want real roots for this, so I want real roots for this. So when can we obtain real roots here? We can obtain real roots when discriminant is positive or equal to 0, right? In either case we get real roots. When discriminant is positive, you would get real and distinct, and when discriminant is equal to 0, you will always get real and equal. Okay, so you must do this. So discriminant is positive, say discriminant b square minus 4ac is either positive or equal to 0. So we require this one, right? Now what you do? Now you plug in this. So now what is b here? What is b? See, b is equal to this, b is y minus 1, okay, and a is y and c is 3y plus 2. So let me plug in this in our case. So you have discriminant b square minus 4ac greater than or equal to 0. Now in place of p you put y minus 1. So y minus 1 whole square minus 4y multiplied by 3y plus 2 greater than or equal to 0. Alright, so you can solve it further. You can solve it. There is no tail in this. So this is y square plus 1 minus 2y, and you get here minus 12y square, and this is minus 8y greater than or equal to 0. So I have y square negative 12y square, so this is minus 11y square, and minus 2y minus 8y minus 10y, and this plus 1 is as it is greater than or equal to 0. Okay, and you can further modify this like this. You multiply the whole by negative sign, so now you would get 11y square plus 10y minus 1. Now greater than or equal to becomes less than or equal to 0 when we multiply by negative sign, right? So that's it. You have this. Now you can factorize this one. You have you can factorize this, and you would get, after factorization, you must get y plus 1 multiplied by 11y minus 1 less than or equal to 0. Now y is equal to negative 1 negative 1 to, now negative 1 to what? 1 by 11. See, there is a cross technique to find its factors of this quadratic equation, and this technique is not applicable for all cases. Okay, in all situations you don't go for this. First of all, you must have real roots for a quadratic equation in that case, and only certain category of real rooted questions will satisfy this technique. But this technique, we can use it conveniently whenever we require. Okay, so I'll go for it. For example, you see what I have is this 11y square plus 10y minus 1 less than or equal to 0. Okay, now this one 11, the factors of 11 is, I can say 11 ones or 1 11s, right? So 1 11, always take the lower factor first. Now you have y square, so y again y. I have y square, so I took y twice. Okay, so y square. And how can we factor this one? This is say I can 1 multiplied by 1. Okay, now we have factored like this. So you see what we have to do now, just multiply like this, just cross multiplication, you will get 11y. Okay, you will get 11y here, and again you just multiply like this. Okay, this one, now you get y. Now what you do now is this, you have here b is equal to positive 10. See this one, you see. So how do we get positive 10 from these two quantities? So I must take plus 11y negative y. If I do this, I'll get positive 10y. Yes or not? So now what you do, so this positive sign you plug in here, and this negative sign you can put it here. Okay, so now what you get from this? Now the answer is 1 into y, that is y plus this one, okay, multiplied by, now I have 11y here, 11y, see this minus we kept all the way here, so 11y minus this one is equal to 0. That's it. So from this what we could get is, so we can get y is -1 and 1 by 11. So therefore the range of y, so finally what is range of y? The answer is this. So finally range of y is -1 comma 1 by 11. So we can also include -1 and 1 by 11. Yeah, so this is how we can tackle this kind of problems. This is very simple problem but very interesting as well. So this this technique is not applicable to all cases, please. First of all, you must whenever you're going to get real roots, only for that case it is applicable, and not, and this this technique is not applicable even for all real rooted problems, but this will be handy at times. Okay, so that's it for today. Thank you.